Let's solve these equations algebraically. Okay, so algebraically what we want to do is we want to get rid of the square root. We want to be able to undo the square root. Now be careful, because if we try doing something like this, squaring both sides like this, we cannot undo the square root when there's pluses involved here. Okay, square root and plus and minus are not compatible. It's very important that we recognize that square roots and squares are not compatible with plus and minus. So we want to first of all undo that plus with a minus, so we end up with 5x minus 1 is equal to x minus 3. Okay, we want to undo the square, we want to undo the square root with a square, and this is where we could potentially generate an extraneous solution. Now we could also work out our extraneous solution by working out our domain restriction here. So if I were to work out the domain restriction, my domain restriction from this point would be my inside restriction. Remember, there's an inside restriction that must be bigger than 0. There's also an outside restriction that must be bigger than 0. So we know that x must be greater than or equal to 1/5. We also know that x must be greater than or equal to 3. Okay, together this domain becomes x is greater than or equal to 3. Okay, so what we could do when we get our algebraic solutions, we can check it against that domain, okay, or we can just plug it in. Again, as I mentioned earlier, that it's probably easier that we just plug it in. We just calculate it and see if it works. Okay, that's going to be our kind of our go-to method when we get stuck. Okay, if we want to try doing the domain restriction, that's a little bit more analysis, which is important to be able to do. But right now, if we have difficulty doing that, we always go backwards and use an easier solution or an easier strategy. So here I'm going to end up with getting rid of the square root. I have to remember that there's a minus there, so I have to FOIL. Okay, it's a quadratic, so I need to make it equal to 0. So I'm going to minus 5x from both sides. I'm going to add 1 to both sides. Okay, this looks like it's factorable. X minus 10, x minus 1. So we end up with x is equal to 10 and x is equal to 1. Okay, now based on our domain restriction, it looks like we can get rid of this 1 as a possibility. Okay, but we're going to check. Okay, we're going to check our solution. So let's test our solution. So we're going to test x equals 10, plug it in. We're going to end up with square root of 50 minus 1, which is 49, plus 3 equals 10. So we get 7 plus 3 equals 10. Yeah, that's a good solution. Okay, so we'll give the 10 a check. We're going to test x equals 1, plug it in. We're going to end up with 5 minus 1, which is 4, plus 3 equals 1. Okay, so we're going to end up with 2 plus 3 equals 1. That's not true. That's extraneous. Okay, so we're going to say that that's an extraneous solution. And we always have to check for extraneous solutions. Okay, so here again we should be able to set up our domain. Okay, and again we could use our domain to test for extraneous solutions, but again we're just gonna make sure that we know how to do our domain first. The inside restriction is x has to be bigger than -2, greater than or equal to -2, and the outside domain, because the square root has to equal positive, for this to be positive or 0, it's going to be x is greater than or equal to 5. Okay, so these two together become x is greater than or equal to 5 when we put those two restrictions together. Okay, so that would help. If we want, we can use that to test our extraneous solutions. Okay, here we can substitute it in. Okay, so here I'm going to undo the square root with a square. X plus 2 equals x squared, and make sure you FOIL that out, 10x, it's 25, negative 5 times negative 5 is going to be positive 20. Okay, it's a quadratic, make that equal to 0, subtract x from both sides, subtract 2 from both sides. Okay, so 23 is a prime number, so it looks like that there's not much choice here to factor. So it looks like it's not going to solve by factoring. So I'm going to solve this by quadratic formula. So I end up with 11 plus minus 11 squared minus 4 times a times c. And that's all over 2 times a. Okay, so this ends up being, what's that going to be? That's going to be 121 minus 92. Okay, so we end up with 11 plus minus square root of 121 minus 92 gives me 29 all over 2. Okay, so then we can check this against our domain. This one's going to be a little bit hard to plug in. Okay, we can estimate the value of this decimal, and then we could plug in and do a calculation of this. Okay, but this one might be easier to test it against our domain. Okay, so we're going to go 11 plus square root 29 divided by 2. Okay, then we get 8.19. Okay, and then minus, we get 2.81. Okay, so it looks like that 2.81 is going to be an extraneous solution. Now, again, we could just, if we understand how to use this domain restriction, and we're confident with that, we can say that the 2.81 is our extraneous solution. We can still test it. Okay, now, when we test this, we're going to have to use kind of decimal values. So when I work this out, this is going to be 10.19 is equal to 8.19 minus 5. That's going to be about 3.19. And the square root of 10.19 is approximately equal to, is equal to 3.19. Okay, so we get this is going to be x equals 8.19. Maybe I'll just draw this a little bit more clearly. So we're testing x equals 8.19. So we end up with 10.19 is equal to 3.19. And that's approximately true. Okay, so we'll put a check underneath that one. That one is a good solution. When we test 2.81, okay, we're going to end up with square root of 4.81 is equal to negative 2.19. Well, this is clearly not true. This is not equal. That must be an extraneous solution. Okay, and again, when we check it against our domain restriction, it is consistent with how we would have, what our analysis would have been with the domain restriction.